save time on question number 3, we are only going to do A for proofs. You can try B on your own for your own practice. If you want, I have B on previous videos online. I'm going to first draw the line. I'm going to draw it sort of in the middle there. And in a proof, if you have a double angle identity on one side, but not a double angle identity on the other side, then most likely you're going to want to use your formula to get rid of the double angle identity. Now, the bottom of this side, super easy, because there is only one formula for sine. 2 sine theta, cos theta. That is the only thing you can change the bottom. But there is going to be one that is better than the other ones for the cos 2 theta. See if you can look at all 3 of them and figure out which one is going to be the best. Just wait. Let everybody look. Don't say it. Mateo had his hand up first, so I'm going to ask him. In the meantime, I'm going to change this to sine and cos. So the left side is cos theta over sine.
You know what would be really funny if you kept that up there but erased the con again, and then tomorrow handed out just a stack of blank papers to your class.
Or just do an actual test.
Just give them an actual
to
test.
My period 6 class.
No, not to your
To
period
see if
6
they're
class.
listening and nervous.
Yeah, not to your period 6 class. I won't be here tomorrow. I won't be here period 6 tomorrow.
We'll wait until the next time Callan is here. And then I'll leave this up.
My memory.
And when he arrives, it'll just be like this.
Math C test. You won't know if it's a memory. It's a memory check. Here we go.
Okay, which one did you think?
2 cos square alpha minus 1.
This is the best one. Why? The minus 1 and the plus 1 will nicely cancel out. There's no 1s on this side, so it sure be nice if that canceled out. Yes.
Do you have to only replace it with the 2 cos theta? Or like in one of the formulas, like if 2 cos theta equals 2 cos squared theta minus 1, could you just add the 1 to the other
Yes.
side and subtract the whole
Yes.
thing?
So if you did one mental math manipulation, right, and just said, hey, I can put the plus 1 to that side and get cos 2 alpha plus 1 and do a direct substitution, perfectly fine. That will do the same thing as this will do, right? Because you would just get this on the top. Same thing here with the 1s cancel out. And can you see your 2's nice and simplified? And one of these coses will cancel it with this cos on the bottom, leaving us with cos theta over sine theta.
So is there going to be a secret check your understanding number 5? You said you'd be doing 5 check your understandings today.
5 questions, examples today. So we've got questions for practice on this one with proofs 10, 11, and 17. Okay, now before we do example 4, turn to page 666. Do some devil math. No, because we're doing enough math that we need the bottom of 666 and 667.
Oh, delightful.
So this goes back a little bit to chapter 6 and combining chapter 6 with chapter 7. Chapter 6 we did lots of solving. But now we're going to solve and need to use our identities within the questions to help us solve them. So some strategies. If possible, and we've used this strategy already in chapter 6, write it with only one trig function. Remember those ones where we replaced a sine squared with 1 minus cos squared? Or a cos squared with 1 minus sine squared? So that the entire function had the same one. We've done that already. But now we're going to also use our double angle formulas. We have to look for factoring. Factoring out a common factor will be very important. And sometimes none of those strategies work. So you go to a similar strategy for proofs. Just change everything to sine and cosine, and then get rid of fractions and see what happens from there. So here is our first example. Solve for theta between 0 and 2 pi. And we have cotangent theta equals 2 cos theta. I look at strategy number 1. Is there any way to change cotangent to cos or cos to cotangent? No. You can't get it only in one trig function. All right? Any double angle formulas? No. Anything to factor that's in common? No. So this is one we're going to change things to sine and cosine and get rid of fractions. All right, so I can change cotangent to cos theta over sine theta, which gets me a fraction, arg. But I can get rid of a fraction in the equation. How do I get rid of the sine theta on the bottom? Multiply both sides by sine theta. And I would get cos theta equals 2 cos theta sine theta. And this is actually similar to some questions I gave you on take-home quizzes. On the first take-home quiz. Question number 2, I'm just marking that one right now. Okay? I'm going to write in big letters factor. The temptation right now is to divide both sides by cos. It works out beautifully. There's only one tiny little thing wrong with it. Okay? Like, can you see if you divide both sides by cos, the coses go away, and you only have one trig function, which seems like a really good idea. And it is a really good idea. It just will make you miss some answers. So if you are ever tempted to make something easier by dividing, factor instead. And in order to factor, they would both have to be on the same side. So I'm going to make one side equal to 0. And then there's a common factor of cos theta. The same thing you wanted to divide by, factor it out instead. If you had divided, you would have got this solution. Sine theta equals 1/2. Go to your pi plate, quadrant 1 and quadrant 2. And you would have been happy that you got 2 right answers. But if you had divided, you would have missed that cos theta could equal 0. And so dividing by 0, apparently it's bad, from what I've heard. So you might have accidentally divided by 0 without knowing it. Is cos theta ever 0? Yes. What's your x coordinate? At pi over 2 and 3 pi over 2. So that's why it's really important that you factor instead of divide, because you might have accidentally divided by 0. Okay? Don't you hate when you learn something new this is like, oh great, I learned something new, and now something that I used to be able to do okay just got harder. Like that doesn't seem fair. That's going to happen again. Okay? Let's see. Oh, I've got special notes for myself where to go. Go to slide 20. 21. You can continue on 666, or you can do this on 667. We now have sometimes that you have a 2 theta and it's a multi-revolution question, which we already learned. And they're like, I can kind of do that okay by now. But now sometimes 2 thetas are double angle identity questions instead of multi-revolution questions. See what I mean? By learning something new, make something previously that you knew how to do a little bit harder. Now you have a choice. And depending on what you do in that choice might work or might not work. So, the multi-revolution questions, if the only thing that you have is the double angle, then solve it like we used to solve it for multi-revolution. But, if you have the double angle and another trig function, then you should use an identity. So I'll let you write that down. So this side is multi-revolution. You would get it by itself. You would say, well, normally x is between 0 and 2 pi, so 2x's would be between 0 and 4 pi. You solve for 2x, root 3 over 2 for cos. That's your pi over 6 family. Quadrant 1 and quadrant 4. That's the first time around. And second time around would be 13 pi over 6 and 23 pi over 6. Because you have to go 2 times around because it's a multi-revolution question. And then solving for x just means dividing them all by 2. The other one, though, has a sine 2x and a sine x. That says you should change it to one of its formulas. And if you're tempted to divide here, factor instead. And everything's on your pi plate. Sine is 0 at 0 pi and 2 pi. Cos x is a half pi over 3 family. Questions for practice on these. I'll leave question number 4 in your textbook for you to try on your own. I do have a video of question number 4.